This is the 10.2 extension graphing in intercept form. This will show you a simpler way to graph than what we've done in 10.1 and 10.2 up until this point, and the reason that we've been concentrating on factoring so much in Chapter 9. The solution to a quadratic equation, that is what x equals, what we were finding in Chapter 9, is actually the x-intercept of the parabola. Okay, so when you factor something and set the parentheses equal to 0 and solve for x, you're actually solving for the x-intercepts of the parabola. Therefore, once you factor a quadratic equation into this form, y equals a times x minus p, x minus q, the x-intercepts of the parabola will be the p and q values. That is, what you get when you set x minus p equal to 0 and solve for x, and x minus q equal to 0 and solve for x. The axis of symmetry would be halfway between these 2 points because they're equidistant from the center. So once you have the solutions, the x-intercepts of the equation, you can actually calculate the vertex by averaging the 2 points. So the x-coordinate of the vertex, instead of using negative p over 2a, you can calculate the x-coordinate of the vertex by averaging p and q. You add p plus q and divide by 2, and that will be the x-coordinate of the vertex. So here's an example. We're going to graph a factored quadratic equation. In this case, y equals negative 1 times x plus 1 times x minus 5. The equation has already been factored for you. Because the coefficient is negative, the negative 1, we know the parabola opens down. The x-intercepts are going to be the solutions to the equation. Set each parenthesis equal to 0 and solve for x. In this case, x equals negative 1 and x equals 5. To find the axis of symmetry, you average those 2 points. So we're going to add negative 1 plus 5 and divide by 2, and that gives us 2. That's the x-coordinate of the vertex of the parabola, or the line that is the axis of symmetry. To calculate the x-coordinate of the vertex, the y-coordinate of the vertex, you're going to substitute that point back into the original equation. So the y-coordinate of the vertex is negative 1 times 2 plus 1 times 2 minus 5, and that equals 9. That means the vertex is 2, 9. You can now graph this parabola. You have everything that you need. You have where it's crossing the x-axis, and you have the vertex, and you have the shape. So you can actually connect those 3 points to graph the parabola. But sometimes you won't have it in factored form. As a matter of fact, most times you will not have the quadratic equation in factored form. So you have to factor it. Then you have to solve it to find the x-intercepts. In this example, we're going to graph y equals 2x squared minus 8. So the first thing you need to do is factor it. I'm going to pull out a common factor of 2, so I get y equals 2 times the quantity x squared minus 4. But we recognize right away that x squared minus 4 is the difference of 2 squares. So we're going to break that down into x plus 2 times x minus 2. Now we can solve for the x values. X equals negative 2 and positive 2. Those are the x-intercepts of the parabola. Because the coefficient of the whole thing is a positive 2, we know this parabola opens up. But now we need to find the axis of symmetry and the vertex. The axis of symmetry is the average of those 2 points. So it's negative 2 plus positive 2 divided by 2, and it is 0. So this runs right up and down the y-axis. If x is 0 for the axis of symmetry, then what is the y-coordinate of the vertex? You plug 0 back into the original equation and solve, and you get negative 8. So the point that is the vertex is 0, negative 8. Because this parabola opens up, this is the minimum or the lowest point of the parabola. You're going to start at 0, -8, and then you're going to put the two x-intercepts in, 2 and -2, and connect those 3 points.